Let's take a look at this problem. We got f of x is equal to 2 over x squared minus 8x plus 12. Now, first thing we want to find is domain. Well, with our domain, if you got a rational function is a single fraction with variables in the denominator. Then what you do is you set your denominator equal to 0 and you solve it. So we got x squared minus 8x plus 12 equal to 0. Now this factor is using the PST method. So this will factor as x minus 2 times x minus 6 equal to 0. Zero factor property says you get 0 on one side, you factor the other side, you set each factor equal to 0, then solve it. So I got x minus 2 equal to 0 and x minus 6 equal to 0. So that gives us x equals 2 and x is equal to 6. Now these are the values that cause us problems. If we put 2 or 6 in the original problem, then we're going to get 0 in the denominator, which we can't have. So we'll put a slash to these. X cannot equal 2 and x cannot equal to 6. Now second thing, let's try it again. It's actually A and B. Second thing we want to find is the x-intercept. Now, if you have a want to find the x-intercept, you want to plug 0 into the other variable. So plug 0 in for y. So we got 0 is equal to 2 over x squared minus 8x plus 12. Now, whenever you have a single fraction equal to 0, you can set your top part equal to 0. So we set 0 equal to, which we don't have a variable, which means there is no x-intercept. Our y-intercept. You always plug 0 into the other variable, so plug 0 in for x. So remember, f of x is like y. Y is equal to 2 over 0 squared minus 8 times 0 plus 12. Those drop away, and we got 2 over 12, which gives us y is equal to 1/6. Now D, our vertical asymptote. The steps for finding vertical asymptote says factor the top, factor the bottom. Well, the bottom part factors as 2 over x minus 2, x minus 6. We just found that over here. Now our next step for finding vertical asymptote is cancel. There's nothing to cancel. Third step is to set your denominator equal to 0 and solve it. So we'll set the x minus 2 times x minus 6 equal to 0. And we already solved it over here. So we know we get x equals 2 and x equals 6. Those are our vertical asymptotes. The reason why the graph doesn't exist there from A is because they're vertical asymptotes there. E, horizontal asymptotes. We look at the degree of the top, degree of the bottom. The degree of the top, degree is the largest power of x. Degree of the top is 0. Degree of the bottom is 2. So degree of the bottom is larger, which means your horizontal asymptote is y is equal to 0. Now our slant asymptote. In order to have a slant asymptote, your degree of the top must be exactly 1 larger than the bottom, which it isn't in this problem. So we don't have a slant asymptote. G, I'm assuming, is increasing, decreasing? Yes. Okay, well, we need to find our derivative. So we got f of x equal to 2 over x squared minus 8x plus 12. The top here will be p, and the bottom part will be q. I need p prime and q prime. P prime, the derivative of 2 is 0. For q prime, the derivative of x squared minus 8x plus 12 is 2x minus 8. So we've got p prime q minus p q prime over q squared. Now we're ready to plug into our formula. So for f prime is equal to p prime, which is 0, times q, which is x squared minus 8x plus 12 minus p, so minus 2 times q prime, which is 2x minus 8, all over q squared, which would be x squared minus 8x plus 12 squared. Well, 0 times anything drops away, so that goes away. And here, I could factor a 2 out of the 2x minus 8, but probably doesn't benefit us a whole lot. Now this bottom part is x squared minus 8x plus 12 squared. We could factor that too. We've already done that a couple times already. That factors as x minus 2 times x minus 6, all to the second power. Let's go ahead and do some more factoring. Like I said, it doesn't benefit us a whole lot, but it'll make the next step easier. So factor out 2 out of the top. We got negative 2 times x minus 4. And down below here, we're going to have x minus 2 times x minus 6 to the second power. Okay, to find our critical values, we're going to set the top part equal to 0, bottom part equal to 0. Well, the top part is negative 4 times x minus 4 equal to 0. And the bottom part will have x minus 2, x minus 6, all of it squared, equal to 0. Well, over here I can, this is already factored, so I can drop the negative 4 and set the x minus 4 equal to 0, and we get x equals 4. Now here I can drop the squared, and then I'll have x minus 2 times x minus 6 equal to 0. We've already solved this a couple times. So this gives us 2, and this gives us 6. Okay. Well, we're going to have x equals 2, x equals 4, and x is equal to 6. We'll build our table of intervals. We'll choose test cases. Clear over here is negative infinity. Clear over here is positive infinity. We want to choose something between negative infinity and 2, like 0. Something between 2 and 4, like 3. Something between 4 and 6, like 5. Something greater than 6, like 7. Now this is real easy to figure out whether it's increasing and decreasing. Notice up here, the bottom part is squared. Whenever you square something, it's positive, so we don't need to worry about that part. On the top part here, negative 2 times 2 is negative 4, so that's going to be negative. Always. Doesn't matter what we plug in for a test case, that part's negative. The question is, what is the sign of the other piece? If I put 0 in, 0 minus 4 is negative. So a negative times a negative is positive, so this is increasing. If I put 3 in, 3 minus 4 is negative. Negative times a negative is positive, so it's increasing. If I put 5 in, 5 minus 4 is 1, that's positive. Negative times a positive is negative, so this is decreasing. And if I put 7 in, 7 minus 4 is 3, that's positive. Negative times positive is decreasing. Now if you don't see that, well then just plug it into your x and go through all the calculation. You'll find out the signs and confirm that. Okay, so this is increasing from negative infinity to 2. It's also increasing from 2 to 4. Then it's decreasing from 4 to 6. And then it's decreasing from 4 to infinity. H. Okay, it's still got this as K, but that's okay. H, our min and max. Our min and max is where it changes from increasing to decreasing. Well, increasing, no change there. But here it goes from increasing to decreasing. So this is a potential max. We'll come back to that. Over here is decreasing, doesn't change. We do have to confirm that this exists. So let's go up here, see what our domain is. We said our domain is x cannot be 2, x cannot be 6. Well, it exists at 4, which means we actually do have a max there. So we're going to take that 4, plug it into our original function. Plug it in here. That'll give us our y part. And I'll do it down here, I guess. Y equals 2 over x squared, so 4 squared, minus 8 times 4, plus 12. 4 squared is 16, minus 32 plus 12. 16 minus 32 is negative 16, plus 12 is negative 4. Yeah, negative 4, which gives us negative 1/2. So our max is at 4, negative 1/2. Okay, now we're ready to graph this. Yeah, I'm not sure how good my graph will be here, with how small I'm making it, but we'll see. Let's see. I'm looking for extreme values, like 6 is pretty big. Everything else is fairly close, so 6 is the furthest one out. So we got vertical asymptotes at 2 and 6. So we got 1, 2, 3, 4, 5, 6. So vertical asymptote at 6, and a vertical asymptote at 2. Okay. Horizontal asymptote, y is equal to 0. So here's my horizontal asymptote. That's the x-axis. Now we said there was no x-intercept. Y-intercept is 1/6. So 1/6 would be right there. Okay. Let's take a look at our increasing. Increasing from negative infinity to 2. Well, since there's no x-intercept at all, I know it can't go down below this line. And since this is a horizontal asymptote, I know it's skimming it anyway. So I know it's coming along here, skimming that, getting real close to it, but never touching it, never crossing it. It's crossing here, and then it's coming up here and skimming this vertical asymptote like that. Okay, and then it's increasing from 2 to 4. Here's 2 and here's 4, so it's increasing there. Where's 4? Okay, increasing there. Let me think about this for a minute. Increasing, then decreasing. Oh, it's got a max. Okay, I'll wake up. 4, negative 1/2. 1, 2, let me draw a sketch that. 1, 2, 3, 4, negative 1/2 would be about right there. It can't change like that unless you do have a min or max. So, okay, so that makes sense. So it's increasing, then decreasing. It's skimming these, so obviously it has to go like this. No way you can draw it. Okay, then it's decreasing from 4 on, and since it doesn't cross the x-axis, there's no x-intercept over here, I know it has to just be up here. Because if I drew it down here, it'd be increasing, not decreasing. So it's down here, and it's going like that, more or less. Let's plug this in our calculator and see what it looks like. Again, the trick is put parentheses on top, parentheses on the bottom. If you have more than a single number or a single variable. We have a single 2 up here. We don't need it on top. We definitely do on the bottom. So let's graph that. Press y equals clear. 2 divided by, beginning parentheses, x squared minus 8x plus 12, close parentheses, graph. And you see, I more or less got it. This should have been a little bit closer in, but we'd only find that out if we plotted points and so forth. So that's good enough for a sketch. That's our answer. Answers, I should say.